the proficiency training session. We have our first session scheduled today at 3 p.m. For that, we have our esteemed speaker, Mr. Hemant Tendolkar, who is an enterprise architect at Tata Consultancy Services. Sir, we extend a very warm welcome to you and our sincere gratitude for you to be a part of this session and providing valuable insights and exposure in terms of the AI cloud, Amazon Cloud Services, and cloud services under the heading GCP. I would request you to take over and start the session, sir. In case of any queries, you are requested to post your questions on the chat. Also, request everyone to stay on mute when the content is being delivered by a esteemed speaker. Thank you.
Thanks, Abhishek. Am I audible, loud and clear?
So you audible, sir.
Yeah, okay. Just give me a minute while I share my desktop.
Sure, sir.
Yeah. One minute. Just a little late. Let me know if my screen is visible now.
Sure, as of now, it's not visible. I guess it's loading. Yes, sir. We have your screen, sir.
It's visible? Okay.
Yes. Yes.
Okay, so good afternoon, everyone. Happy to conduct this session on Google Cloud for all of you. So essentially, I don't know how much interactivity might be there in the session because I believe we are on YouTube Live. Maybe Abhishek, you will be taking care of any questions or queries, etc., that come on chat or something.
Sure. Sure, sir.
Yeah, okay.
We'll be looking at that, sir.
Sure. Okay, fine. So I'll take it forward from a Google Cloud perspective. So usually the way, we start, and a disclaimer here, essentially in TCS, we have a lot of training material that we create on our own, and as well as, access to training from these cloud vendors like Google, Azure, etc., because we are partners with them. But unfortunately, we cannot share any of those materials. So what I've done out here is I have picked up this PDF which I found on the internet itself, which I felt pretty much captures the essence of Google Cloud. Concepts. It's by Linux Academy. Okay, and if you just Google for Google Cloud platform overview, I'm sure you will come across this link in the very first page. Okay, so that's a disclaimer from my end that I'm reusing, a training material that's freely available on the internet. Okay, so proceeding with that, so I'm pretty sure by this day and age, we don't really need to ask the obvious question that, is everyone aware of Google Cloud, what is cloud, and what is Google Cloud, etc. But just to cover the basics, even this training material and even I wanted to cover in the sense that, what exactly is the cloud. Okay, so the best example that I give, even though the slide actually talks more about a lot of these iCloud and Google Drive, etc. options. The one of the simplest applications of Google Cloud or any cloud for that matter would be say Gmail or Yahoo Mail or any of these mail services, right? So if you compare say a Yahoo Mail with say industrial email, so when we are accessing our work emails, okay, uh, not now anymore. I think with most of the email providers also having gone on cloud, but maybe 5-10 years ago, if you were talking about enterprise email, typically you would have say a Microsoft Exchange server or any of these popular say IBM Notes mail server, etc. So these were some of the popular mail servers which were there, and you had to actually have your own data center. You had to have your own farm of servers where you would bring these DVDs of Microsoft Exchange, and you would install the Exchange server. So you're right from the data center to the machine software. You had to actually purchase the license from Microsoft or IBM, etc., and set up the entire email. Okay, so that is the typical example of what we used to call as on-prem on-premise software. Versus if you take a look at any of Google Mail, Yahoo Mail, etc., uh, these were something that we as users never used to bother about how to install the same, how to configure the same, etc. All we had to go was go to a browser, open the URL, and sign in, and we are good to go, right? So that is a typical example of cloud. So essentially, what is cloud? The idea is that on a slightly lighter note, again, this is another thing which I liked about this particular PDF. They've also put in some few jokes around. So essentially, cloud is nothing but, as this joke says, it's someone else's computer accessible over the internet. Okay, so that's the basic introduction that I can give about, Google Cloud, or for that matter, any cloud. Okay, so the main idea is your data, your applications, whatever you are hosting on the cloud, they are no longer on your own premise, okay, or on your own data center or your own machine for that matter. Okay, it's on the internet, and theoretically, at least, it's available, accessible to anybody from the internet. Okay, so that's the definition of cloud. Now, when we go a little step further, so this is a typical example of a cloud data center. It'll be like a huge, say, factory or a wholesaler kind of a big building, and you'll have rows and rows of these server farms installed over there. So that's what a typical data center looks like. But the moment about cloud, so say if we take an example of TCS itself, right? So TCS, we have our own bunch of applications which we use for payroll of our employees, for tracking work allocations of our employees, etc. And therefore we have our own data center as well. So TCS has a few data centers spread across the world, but at the same time, we also utilize certain cloud products like Google Cloud, Azure, AWS, etc. And that is where the applications which are hosted on those clouds, they are actually no longer in our data center. They are not in the TCS data center. So they are either in the Google data center or the AWS data center, etc. So that's your typical example of how a cloud connection looks like. Okay, so I hope I'm making sense so far. Um, Now, coming specifically to Google Cloud Platform. So, and again, this is also, to quite an extent similar with any of these providers. So, what does a cloud platform typically provide? So, what does a computer typically have, right? So, if you take a look at the computer, except for the input and output devices like mouse and keyboard and your monitor, etc., what is the core of any computer? It's basically your computing or the CPU. Then you have some sort of a hard disk, which is your storage. Okay. And then, you have various applications installed on the computer, right? So that is what is similar to the services that are offered by any cloud provider for that. So you will have compute services where you can actually have these virtual machines which you can spawn up. So instead of having to buy a server, from say a Lenovo or a Dell or whatever, uh, all you have to do is the server purchases and everything. Google or AWS has already done for you. The moment you need, a certain say. CPU with say 32 GB RAM and 500 GB hard disk, etc. All you have to do is just fire up one virtual machine, and your billing also starts at the same time. You can start using it as well, right? So that's what is a computing service. Similarly, you have storage services. So just like you would suppose you're running out of space on your local hard disk, you would have typically purchased, say a USB extension hard disk or something of the sort. So in on similar lines, you have these various storage options which are there, which are provided by all these players, and your computing. Now, the moment you're talking about storage, the next typical application of these storage devices would be, apart from storing files, you would also like to store data. Okay, so databases come into the picture, big data comes into the picture, where we are talking about data warehouses, etc. Moment you have data warehouses, you will typically have some sort of analytical applications which will be there. Then you have cloud security as well. You have a lot of developer tools which are available to you, which you can use to build applications on the cloud, etc. And then, of course, the flavor of the last few years, ever since ChatGPT broke ground, machine learning and AI related services, right? So these are a typical representation of the kind of services which are available on this Google Cloud platform. Okay, so the idea is that any of these services, if you want, instead of the old way of purchasing hardware and hosting it in your own on-premise data center, etc., all you can do is in a matter of seconds or minutes, you can fire up any of these services and start using them. Okay, so that is the core concept of any cloud platform. Okay. So again, I'm taking a pause here, letting that information sink in. I hope it's useful for everyone out here. Yeah. Vishek, any queries, anything so far that I need to attend to
So we're
right away?
good to go as of now. Actually, we have turned off the option for chat. Probably in the last 15 to 30 minutes, we're gonna turn on the chat option so we can take up the queries in the end of the session, sir.
Sure, sure. Okay, that's fine. That's fine.
It's going
Okay,
great, sir.
so
Yeah.
yeah, sure. So now taking a look at some of the, again, this is again in a way talking about the same thing that we were talking about earlier, that when we are having our own computer, etc., how do you take care of things like backups, sharing information, etc. So there are various options which are, so for example, Google Drive, iCloud, Dropbox, etc. There were, of course, physical options also like the USB zip drive, etc. But here we are talking more in terms of the application, scenarios. So these are some of the features that most of these cloud providers, again, use. Now, if we take a look at some of the common enterprise use cases, okay, where we as in TCS, so quick background on myself. I've been with TCS all my career of 25 years. So I was very much, born into the on-prem era. Unlike most of the current generation, all of you, who are more born in the AI era or the cloud era. So I have actually seen these, kind of progression where earlier we used to have, users, applications, servers, etc. And as this slide is trying to explain, so suppose you are, say a startup, okay, in the year 2016, you are a startup and you had a few users who are using your application, etc. And you purchased, some servers and you wanted to, these servers were sufficient for your usage. But the moment your startup, suppose, becomes a hit, and you start seeing more and more users coming on board onto your application, whatever is your service that you're providing, you will have to exponentially, according to the requirement, keep increasing these racks of machines. And pretty soon, you will run out of physical space in your, whatever office premise, whatever you might have taken. Then you might have to take a larger, premise on rent or, purchase, etc., whatever. So that's a typical, scenario of enterprise users as well. How, the demand was increasing so much. And again, since I've been part of that era when we didn't really have this cloud option, I very clearly remember we were in a project, where we were starting this Siebel CRM implementation. And I still remember it took the client. So we were implementing it for one of our manufacturing clients in the US. And the client had to spend almost a month or a little over a month to just provision certain development servers. Okay. So that was the time that was required for actually purchasing servers, from the market and getting them into the client's data center and having the infra team set up the operating system on those servers, then setting up the application on that server. It was at least a month, month and a half just to give the development specification kind of machines in. So for that month, month and a half, I still remember we had started setting up the team, and most of us were busy, just undergoing training on Siebel CRM and stuff like that. Okay. So now that the development servers came within a month or two, I still clearly remember that the production grade servers, which were actually going to host our application when it was going to go live, that took a nice, 5 to 6 months for those machines themselves to come up. Okay. So that's the, kind of time frame, because all these things, if you look from a company point of view, right, you cannot just go to the shop and buy a server and install it and you're ready, right? You have to go through a lot of formal processes. You have to first, get the budget approved. You have to get the various specifications clearly called out. Suppose today you think that, say, 32 GB RAM is sufficient and you put in that request, and when 3 months later, when the request actually gets approved by all the approvers, and you actually send out the quotation to the vendors and you get back the responses on those quotations and you finalize a particular vendor, easily 2 to 3 months will go, and for all you know, you might think that, okay, 32 GB is too low for me. Okay, so I might have to go with, say, a 64 GB RAM or something. So these kind of changes, main that we are trying to say out here from this slide is that any kind of expansion in on-prem, infrastructure used to take a lot of time, space, and also a lot of initial, expense that you had to put in just to make sure that your machines are in. Okay. And then the moment, more and more, and yeah, so the next scenario that they're depicting is, suppose for some reason, okay, suppose you have some downturn in your business cycle, or say maybe not 2018, but suppose it is 2020, or when the COVID struck us. Okay, so suddenly the user demand goes down. Okay, and from 20,000 it comes down to 7,000 users. What do you do with these extra machines that you purchased, right? You don't really need them anymore. So this is the concept what we also call as business elasticity or agility. Okay, where when you're purchasing machines upfront, you cannot really purchase them quickly enough, nor can you get rid of them quickly enough. Okay, so sometimes, a lot of the businesses that we see, especially things like, say, retail, consumer goods, etc., they are very cyclic in nature. Okay, you will have a peak season kind of a thing. Say, for example, recently we had Diwali, Dasera deals, etc. So a lot of the retailers will have a huge amount of demand, and then again, there'll be periods when there'll not be much activity, and every year you will see some sort of a seasonal pattern. So what do you do in such cases, right? When during peak demand you need more hardware, more infrastructure. You cannot just buy it immediately, nor can you get rid of it the moment you're done. But the moment you're talking about something like a cloud, you can very easily deploy all these functionalities. The moment you see a rise in demand, there are few auto scaling, etc., where you can actually increase the number of CPUs that are there with you. The moment the demand goes down, automatically the extra CPUs will shut down, etc. So all these kind of features are easy to use, on the cloud, much more convenient than it is on the on-prem systems. Okay, so that's the purport of this. So this is what the next slide is showing. So automatic, scaling of, your servers increase, your users increase, you can increase the servers. The users go down, you can bring them down, etc. So this is one of the features of cloud in general, and of course provided by Google Cloud as well. So you have fault tolerance, high availability, scalability, and elasticity. So these were the four topics that we covered so far. Fault tolerant was all about, and we'll take a look at each of them in detail as well. But the idea is that because Google, Azure, all these providers, they have data centers in multiple locations across the world and even within countries. Okay, so within India, typically you'll have data centers spread across Mumbai, Nagpur, Chennai, Delhi, Lucknow, Kolkata, etc. So even within a country, you have multiple regions and availability zones, etc. Are the terminologies that I use. So any one particular data center goes down for whatever XYZ reason, you can always go back to the fault tolerant server which is there. Similar concept with high availability. So make sure that any downtime are minimized. You don't really need large outages for maintenance activities, etc. You can have a highly available backup with you. Scalability is all about you're talking about the ability to ramp up easily. So or even there are features like suppose today you have a startup and you have your products which you're selling within India. Tomorrow you want to sell them out of Europe as well. So what do? In a normal scenario, you would have to send somebody to any of the European countries, finalize some office space, purchase some hardware to host your website over there, so that it's accessible quickly, etc. And that kind of a concept you'll have to, obviously it will take a long time, right? But with global cloud providers like Google, all you have to do is specify that, okay, tomorrow I want to set up my clone of or replica of my website in, say, France or Spain or Germany or US or anywhere. And within minutes, again, there are services such as CloudFront from AWS, etc., which can immediately replicate your website and make sure that users who are going to your website, same domain name, if they are coming from US, they access the server from the server which is there in the US. If they're accessing from Europe, the traffic will be routed to the servers which are in Europe, etc. So that way, again. Highly scalable, highly very easy to provision all of these things on the cloud. And then we took a look at the elasticity as well. Depending on user demand, we can increase or decrease the the uh, consumption of your various resources. Okay, so these are the four concepts we have covered so far. Now, taking a look at something known as virtual private cloud, and how do you actually make sure that your users are reaching the correct place. So the compute engine. Okay, so these are some of the typical services which are used. Okay, you have compute where you have various kinds of hardwares and virtual machines which you can use. You have different types of storages which are available. So object storage, data storage, file storage, etc. You have various big data services as well. When we are talking about unstructured data, social media, posts, blogs, videos, reels, all this kind of data, and then even machine learning related services. Okay, so if I take a look at any of the, say the compute engine, these are some of the, typical uh, terminologies. So in a example of on-prem, we used to have a computer which was a CPU, RAM, and hard disk, and now you have a compute engine. Okay, a Google terminology for what is generally known in the industry as virtual machines. Okay, so when you fire up a Google compute engine, it has a and you can specify what kind of a server do you want. Okay, so what CPU, RAM, storage, etc. do you want on the server? Then what kind of network is that server located in? How do you want to protect it? Does it have to be freely available on the internet, say for some public website, etc., or should it be entirely accessible only from within your company networks, etc.? So all the firewall and security you can take care of. You can even specify which operating system do you want. Do you want it to have Windows, which version, Linux, which version, etc. So all those details you can specify when you are purchasing a compute engine product from Google. Okay, so that's your typical virtual machine offering from Google, which is called as compute engine. Okay. Now, typically, some applications, so Spotify, etc., is a typical, I'm sure quite a super hit service. So that is something that's hosted on Google Cloud. Okay, so that's your compute engine. Now, the moment you have a compute engine, the next is where do you host that compute? Okay, so that's where a concept of virtual private cloud comes into the picture, where your compute engine, how accessible is it? That's what you're trying to define. So virtual private cloud is essentially, think of it as a cloud which is accessible only to your own machines or your authorized network. Okay, so on the one hand, you have the public internet where anybody and everybody can go to any website, but at the same time, the moment you want to have your own home network, so typically you have a printer, machine, etc., your laptop, desktop, mobiles, etc. So the concept of a home router, okay, is essentially in a way mimicking your virtual private cloud. So the home router is while on the one end it is connected to the internet, on the other end you can also specify that, okay, I want certain devices to be accessible only internally. I do not want anybody on the internet to be able to access my laptop or say my mobile, etc. But from my laptop, I should be able to access my mobile or vice versa. Or from my laptop, I should be able to access my printer, but nobody else from the internet should be able to. Okay. So typical scenario at back at our houses. So same concept applies to the virtual private cloud. It's a home network of your particular company. Okay. So whenever you have the option to have a internet connection also, and then you have the option of having internal or intranet connections to this compute engine. Okay, so that is what is a VPC in short. Okay, I hope I'm not going too fast. Let me know if you're getting any such feedback. Okay. But so far we have done, exploring certain general options or features of cloud in general, and then we have taken a look at the compute service as well as the, virtual private networking kind of service, which is there in Google Cloud. Now we'll step into various database options which are there. Okay. So again, so when you're talking about databases, okay. So typically, we used to have long back. We used to have things like structured data, where you used to have tables and columns. Okay, so tables with rows and columns. So that is your typical example of a database. But then at the same time, why do we need to take a look at database as a separate, entity apart from compute? Because finally, what is database? Database is nothing but compute and storage, right? But compute and storage, there are different types of databases. Okay, so whenever you have these different types of databases, you have to take a look at various usage of these databases. Okay, so whether they are going to use structured data, if they're going to have encrypted data like say login information or cards information, etc. Okay, whether they're going to have dynamic data such as say inventory which is getting updated every second, every moment there is an order, inventory has to be updated every day in the morning when you are receiving goods from your suppliers, you have to update the inventory, etc. So what kind of access patterns are you looking at? All that actually makes a big difference to the use case that you need for your particular database. Okay, so with the power of various cloud, we'll also take a look at data centers and how they are useful in the various scenarios. Okay, we took a look at this one. So I went back a little bit. Give me a minute here. So okay, we are going back to the scalable fault tolerant. We talked about this. I'll skip these concepts, but coming now to the concept of storage. Okay, so storage is also something which is very important in the use of how do you want to store various different things. Okay, so apart from databases where we are talking about more structured data, your storage, you can have these days, apart from your tables and columns, you have a lot of media which is getting generated. Okay, whether it's documents, whether it's movies, reels, audio files, even this YouTube recording for that matter. When we have gone live on YouTube, somewhere it has to be. This is also known as streaming data. So the streaming data will be there right now. It has to be streamed live as I'm speaking. All of you are able to, hear me on your particular machines, etc. So that is known as streaming data. And at the same time, the moment the session is over, the recording for it will end up generating a video file. Okay, so that's one of the typical use cases of uh, cloud storage. So you have different kinds of data which needs to be stored on the cloud. Okay, so there are different options which are available. Think of another typical term which we use for cloud storage is we call this as a bucket. Okay, so you can have a bucket, and in that bucket you can keep all sorts of things. Okay, so similarly there is this concept of a cloud storage bucket where you can have multiple kinds of data which can be stored. You can have songs, movies, databases, documents, everything in the same storage bucket. Okay, and typically these are extremely scalable to this extent that literally you have unlimited storage. You just have to take a plan that, okay, every few GBs, this is the charge that I'm going to be billed, and you practically have unlimited storage. Okay, that's how these large vendors like Google and Azure and Amazon are operating. Literally limitless amount of storage is available. Okay, so that is your so far the concepts of storage, databases, compute, and virtual private cloud. Okay, so any doubts, Abhishek? Do you think it makes sense to take a pause and take some questions, or shall I just continue?
Sure. So just wanted to know, like what amount of content needs to be delivered more. Accordingly, I'll turn on the chat, sir.
We can have say a 5-10 minute opening of the chat.
Okay,
Let's take a look at the questions. Okay,
sure,
and
sure,
then we can again proceed forward. People can take quick breaks also during
sure,
this
sir.
time.
So I've turned on the chat option. It's a humble
Sure.
request to everyone to kindly post queries regarding Google Cloud concepts. There'll be a general query session scheduled separately in case of any queries related to the traveling, lodging, or being a part of the Smart India Hackathon Grand Finale. You're requested to kindly post queries related to only Google Cloud concepts.
Okay, so Gurudayal, I can see a question about risk, of data privacy, data security, etc. So that's typically a very valid question. This was probably a cause of concern, Gurudayal, maybe 10 plus years ago when cloud was still a new offering, and people were a little skeptical about because finally, see, another concept which I wanted to also share with all of you was, this is a cloud concept called multi-tenancy. Okay, so how do you think a company like Google is able to provide all these limitless storage, almost limitless compute capacity, etc. Today I want to fire up 100 virtual machines on Google Cloud. I can do that. Okay. So how do you think, it is able to, provide this? So the concept behind the cloud is something known as multi-tenancy. You can again look it up. I don't think I have any slides on this in this particular thing, but the idea is that the same hardware is essentially, shared between various tenants or various clients. Okay. So it's quite possible that the same machine, okay, is hosting, say, I'm just giving a hypothetical example, please don't quote me on this, but it's very much possible that the same machine might actually host, applications from, say, both, say, an Amazon or a Flipkart, right? Cutthroat vendors. You can have a same server which can have, say, applications which are shared by the most, say, Pepsi versus Coke. Okay, so these corporations, which are tooth and nail fighting with each other, competing with each other, etc. It's very much possible in today's day and age with the software plus hardware infra that is available to separate out these things. So even if you have the same hardware actually shared between two different companies, there is not much, about not much concerns left now with respect to privacy, data security. Having said that, there was also, I think I saw a question from someone that can you explain the concept of virtual private cloud again? So the idea is that, I'm sure you guys must have heard about this term of, public cloud versus private cloud versus hybrid cloud. Okay. So public cloud is nothing but, your compute and storage and everything available directly on the internet. Okay. So say something like a Spotify, right? So when you are taking a look at the Spotify app, okay, which we talked about, the Spotify app is, the app contents and the website and everything is available freely across the internet. But having said that, I'm pretty sure that if Spotify has, some, say, its payroll application also on Google Cloud, I'm very sure that they don't want to have the payroll application available to everybody, right? Suppose I want to find out what's the salary of the CEO of Spotify, etc. I don't want that to be available to me. So what can be done is, so a part of the so when we're talking about this concept of VPC, let me go back because somebody was asking about that concept once again. So the idea is that your machines are having the option to connect to both internet and intranet. Okay, so this is the slide that I was referring to. So your virtual private network, you can configure in such a way that you can specify that, okay, this particular compute engine which I have purchased, it should be only having private, no public connection. There might be certain compute engines which might be only on the internet, need not be on the intranet at all. And then there can be a machine or a compute engine which is available across both. And you will have to obviously, make sure that you are taking care of the respective security on your own. Okay. So there's also this concept of, shared responsibility. Okay, which is another typical cloud concept. So whenever you are purchasing any of these services from these vendors, okay, suppose I take a compute engine from Google. Okay, so now what Google will make sure is that when that compute engine is provisioned for me, they will give me this option of exposing it on the internet or keeping it within the intranet. Okay. Now that is the responsibility of Google, that I will give you options to enable both. Now, what is my responsibility as, say, if just take the example that I am an employee of Spotify. So when I'm purchasing a compute engine from Google, Google has the responsibility to provide both options. Now it's my responsibility to make sure that I am, configuring this compute engine in the correct way. If it is my public website which has to be accessible on the internet, I will make sure that it has the public connection enabled. But if it is, say, my payroll application has to be internal only, I will make sure that it is available only on the internet. Okay, so that's how you can keep your data safe. So that is where my responsibility comes in. So that is the concept of shared responsibility on any cloud providers, where you have the providers have the cloud providers have the responsibility to give you all the options that you might require. But the moment they have given the options, it's your responsibility to configure the services in such a way that you are not your data is kept secure, data privacy, data security, etc. concerns are taken care of. Okay, so I hope with that one example, I could answer those couple of questions. Let me just check the chat, so if I can see any other questions. Arcade is a campaign by GCP competing to Google Cloud Arcade and its benefits. I'm very sorry, Chandra, I have not much idea about Google Cloud Arcade. Okay. Databases services, we'll take a look at, Soumya. What other questions are there? Does Google make a private cloud server every time load into Google Photos? So this question, Hardik, I think you are mixing up two concepts. Okay, so Gmail, Google Photos, etc. All these are public cloud. Okay, but they have the authentication. Okay, so with your ID, your photos and your mail and everything is available only to you. But it's not a private cloud. Okay, it's still a public cloud, because anybody can go to that tribe.google.com, photos.google.com, etc. Okay, so that is an example of a public cloud where you're securing the data using authentication. Okay, I hope I was able to answer that. Is this software or hardware? What is that? Can Google help company migrate from on-prem to fully cloud native? Okay. So, Mithun, to take your question, there are various, migration tools and services which are available. I think I also saw another question of, how do you migrate data from your on-prem database to a cloud database? And similarly, you have applications which are, dealing with, you have to migrate your applications also from on-prem to cloud. So I'll also try and explain and answer your question by explaining another concept. When you're talking about cloudifying your enterprise, right? I'm just loosely using a term. I don't know if it is a valid term or not, but when you're look at moving stuff from on-prem to cloud, there are actually 2-3 different options that you have. The first option is what we call as lift and shift. Okay, so when you're talking about lift and shift, all you're doing is you're actually just moving your hardware or your application software, etc., from the on-prem server. So you might actually physically move the machine or something of the sort, or you can move the image, okay, of your local servers and get them set up on your cloud servers, or you can just do the same installation on a cloud compute engine. Okay, so that is something known as lift and shift. Okay, the other way to look at cloudifying your enterprise is to see if there is a chance to modernize your enterprise. Okay, so when you're talking about modernize, that is where the concept of, suppose, something like a cloud native infra comes up. So if you want to, so for example, if you have a monolithic application, okay, built 20, 30, 40 years ago, especially in IT companies like mine in TCS, we come across a lot of clients where based in the US. I was in a project working from Sweden, where there were applications as old as 40, 50 years old, which was still running perfectly fine. There was no, performance complaints or anything like that. But at the time, maintaining them was becoming a nightmare because those kind of I'm even now. This is a technology Fox Pro or something, if I remember correctly. That was one of the technologies which was very hot in the 90s, but now I'm pretty sure none of this generation of people don't know this term called Fox Pro, Fox Base, etc. There were all these various applications. So if you want to maintain those and just do a lift and shift, it becomes a headache because you will not find developers or experts who are knowledgeable in that area. Okay, so that is where the concept of modernization also comes in, where you don't want to do a lift and shift. What you want to do is you want to take a look at redesigning, re-architecting, refactoring your applications so that you can, a monolithic application, can you make it into a microservices enabled application? Okay. An on-prem one, can you make it into a cloud native infra? Okay. So there are various options which you have to consider first. And then for each of these options, there are various services which either the vendor itself can be providing, either Google might be providing on its platform, or all these cloud vendors also have this concept of a marketplace. Okay, so in the marketplace, you are essentially allowing your partners and various other companies to come up with solutions for these kind of situations or problems. So, on-prem database, say I have a say Microsoft Access database, and I want to migrate the data from that into say a Postgres database, or I have say a bunch of 5,000 documents in my on-prem and I want to migrate that into say a cloud storage option. Okay, so how do I do that? So either Google might provide its own services, or you can have this marketplace apps which can provide you these kind of migrations. Okay, so that's a typical example of how we can migrate. Okay, we've spent about 10-15 minutes on this Q&A. So what I'll do is I'll go back to my material so that we can continue. But let's keep the the chat going after the next break. So maybe half an hour from now, or maybe 20 minutes from now, depending on where I have reached, we'll re-enable the chat, Abhishek.
Sure.
Okay.
Sure.
Yeah. Okay. Thanks. Thank you so much, Abhishek.
Thank you.
So going back now to where we were. Taking a look at various cloud concepts. Now let's take a look at what are managed services. Okay, so managed services are essentially, so for example, we took a look at this compute engine, right, where you have a server which has CPU, RAM, storage, net, etc. Now this is a normal server. Okay, but this is something that you have to deal with it, right? So you have to deal with the various components inside it. A managed service is something which Google will take care of. Okay, so when you say, so for example, so this is there was few questions on different database types. Okay, so a Cloud SQL database. Okay, so Cloud SQL database is nothing but your same SQL Server kind of databases which are managed entirely by Google. Okay, so for example, tomorrow, if you if any of you are fluent with say an Oracle database or a IBM DB2 database, etc. All these databases require constant database administration kind of services. Okay, so you have to continuously keep installing patches to the databases, patches to the operating system on which these databases are there, etc. So instead of you having to manage it, when you go for say a managed service like a Cloud SQL Server, you can directly your Google take care of all the operating system and database patching, upgrading, etc., making sure that the storage is properly handled, etc. While all you have to worry about is take care of the data inside that database. Okay, so loading it, accessing it, using it, exporting it, etc. all that is your headache. So this is what is known as a managed service. If just give me guys 1 second, I'll try and share one more slide from what I had in another PPT. Okay, I hope this again, this is also another very famous thing picked up from the internet, and I'm sure you can also take a look at it. Abhishek, let me know once my screen is visible again.
It's visible now. Yeah.
Yeah, okay. So this is an example of what we call as pizza as a service. Okay, so if you just Google for this term, pizza as a service, a very famous term. So this is trying to explain the concept of on-prem, cloud, and then the various flavors of cloud. So we have something known as infrastructure as a service, platform as a service, and software as a service. Okay, so when we are talking about, if we take the example of pizza as a okay, so when you're doing on-prem, you're talking about, making it at home. Okay, so you have to buy the ingredients, you have to buy the, the hardware that is required to process those ingredients, and then you have to also buy everything that is required to serve the ingredient. Okay, so when we are talking about infrastructure as a service, so this is like a take and bake kind of a option where you can go to a supermarket. I think even in India, Reliance Fresh or Big Bazaar, etc., they have these frozen pizzas. Okay, so you can buy those. So the ingredients and everything somebody else has taken care of. You need to have your oven or your electric, gas, etc., utilities to. Let me just put the pointer. So this portion of the the baking has been done for you, and you just have to take care of the oven and the the serving part. So when you're talking about infrastructure as a service, this is the basic thing where you are buying, say, a Google Compute. So Google Compute is an example of infrastructure as a service. So I am telling Google I need a machine with, say, 32 GB RAM, 500 GB hard disk, and Linux, say, RHEL, Red Hat Enterprise Linux version 7.8 or something. Okay, so then they will give you the machine, and then on top of that, my applications, my everything else is my own headache. Okay, when you are talking about platform as a service, so that is where the example that we were taking of say a Cloud SQL database. So a Cloud SQL database is something where not just the underlying compute, but the database, the entire administration of the SQL database is something that Google is providing. All you have to do is take care of your own data. Okay, so the data is yours, and the cloud database is available to you as a managed service. Okay, so that's your example of a platform as a service or a managed service, as we are talking about. And then finally, you have the software as a service. So typical example of software as a service is, the best individual example can be what we were talking about initially, say a Gmail or, Google Drive, etc. Okay, so you just have to go to mail.google.com, and you can start, sign up, and you can start sending, receiving emails, and start doing your work. Okay, you go to drive.google.com, you can immediately start, storing files, uploading files, sharing files, receiving files from other people, etc. So over there, in a software as a service scenario, the entire application itself is available to you. You don't have to worry about anything at all. You just have to, you can give the application on day one to your users. So a typical example would be, I don't know how many of you are familiar with applications like Salesforce.com, okay, or I think Closer Home. You have a lot of these ERP applications which are available on the internet. So you don't have to worry about the infrastructure. You don't have to worry about the database server, the application server, the integration server, etc. You don't have to worry about the application, building the application also. Everything is available for, all you have to do is sign up and start using it. Okay, so that's the, the most convenient, and mapping to say, so that the pizza comes in. So the first is the take and bake, where you buy frozen pizza from a supermarket, and then you have to prepare it. The second is where you have the option like Swiggy and Zomato nowadays, where you purchase the hot pizza, and it just arrives at your desk and you take it. And then finally, the dining out option is where the SaaS comes in, where you're talking about you can just go to a restaurant and eat. So that table and soda and everything is all, nothing has to be yours. All you have to do is just go and eat, right? So that's typically, I just wanted to bring this slide in to explain this concept of a managed services. Okay. So now when you put all of this together, that is where you will get this example of, so say, let's take a look at these, the physical infrastructure. Okay. So when you're talking about, this is where, I was talking about the initial concept of fault tolerance and all. So this is, I'm sure, probably not the most up-to-date picture of, Google Cloud, but this is a representative, scenario of where all is Google actually located. Okay, so I'm sure by Google is present in more places in India also. I think Hyderabad also they have a data center and stuff like that. But just take a look at this picture as a representation of the global outreach of these large platform providers. Okay, so right from Asia Pacific to Middle East Asia to Europe to the US, North as well as South America, etc. These these platforms are prevalent all over the place. And that is why, and then within these regions, you also have various zones. So, that is where the fault tolerance comes into the picture. So like, for example, in the India region, you will have, zones such as West, India, South, India, East, etc. like that. So there are concepts of zones which give you this, so regions and zones. So here's one region where you have US West. And then within that, you will have zones West 1, West 1A, West 1B, West 1C, etc. So just data is, data applications, everything is well backed up across multiple places. So if I take the example of, say, a cyclone or a tornado or say an earthquake, etc., in these kind of eventualities, data will always be available to you. Okay, that's your typical concept of regions and zones. Then you can have your data spread across these regions and zones. So that's your typical concept of various services which are there from a Google Cloud concept point of view. Okay. Having said all of this, there's also one more slide which I wanted to share with all of you. So this is your typical various services. So when you're talking about we have Google, and I hope this part is also visible to all of you. Let me know if this section is platform. So across vendors, whenever you're talking about cloud, right? So these are your typical services which are available to you, as options across uh, um, the various. So we talked about compute and storage and all those kind of options, right? So when you're talking about these various services, you will have these available to you across the three prominent players that we have. So in the case of Google Cloud Platform, your virtual servers are nothing but VM instances or the Google compute engine that we took a look at. If you're looking at platform as a service, you have the Google App Engine. If you're looking at serverless computing, you have cloud functions. Dockers, you have Google Container Engine, Google Kubernetes Engine, etc. Your storage, so you have Google Cloud Storage. Archival is Google Coldline. Then file storage is Google ZFS or Aware. Then if you have global content delivery, where I was talking about, serving your website in different countries locally. So that is where Google Cloud Content Delivery Network comes into the picture. So you can host your website. Say code is present in, say, India, and then your website replicas are available locally in, say, Europe, US, Japan, etc. So that when users are accessing the application from those countries, they are going directly to the main, the local replica of theirs, so that the speed is quicker. Okay, so that's your. And then what I wanted to mention out here using this slide is, so from these most prevalent application services, you will almost always have options all across these platforms. Okay. So yeah, so that was in a brief, I wanted to capture the various options that you have on Google Cloud, and I wanted to close this particular section by mentioning the equivalent services or options which you have in the other cloud platforms. So I hope this was useful. Uh, we can maybe open up once again, Abhishek, for any more questions. What I was
Sure, sir.
thinking was, I think we have covered only half, the time that was available. We have 1 more hour to go, right, Abhishek?
Right, sir, right.
Right. What I was thinking was, can we take a look at, because AI is such a big flavor. Do we have a separate session on AI itself, or is it something that we can cover to some extent in today also?
So it would be really great if we can cover it in today's session only.
Okay.
Probably, yeah, yeah.
Okay, great, great. Because that's something that I have been focusing on in the last 5, 6 years. So that's why I thought I will, come up with a brief section about AI. Okay, so I'll
Right,
talk a little bit about that also.
right.
Before we go over there, any new questions have come up which you want me to take care of? I can take a look at the chat.
So probably we can go ahead with the new AI part. And around 4:40 or 45, I'm gonna turn on the chat so we can take up the queries later on, sir.
Okay, okay, that works for me also.
Sure, sir. Sure.
So I'll talk a little bit about AI, machine learning, Gen AI, and then also we'll take a look at the Google options which are there, and I'll also talk about a case study which I did using Azure, so that everybody has all these options available. So when we are talking about AI again, nowadays the big craze is all about generative AI, Gen AI, ChatGPT, Llama, and all that. But the way I wanted to start this was that how the software revolution has been in the last 40, 50 years at least. It's also impacted the industry. Okay. So, of course, these terms are something that got coined only in the last few years, but you might have come across these terms called Industry 1.0, Industry 2.0, etc. And we are now currently in Industry 5.0, as we call it. And till a few years ago, it was Industry 4.0. What we are trying to show out here is how this period has actually, the industrial revolutions that have been happening, okay, how they have been impacted by the development of AI. Okay, so when we are talking about the pre-1970s, most of the AI revolution was all about basic uh, you know uh, I'm also trying to depict how the definition of AI itself has changed over the years. Okay, so concepts of word embeddings and bag of words were just coming into the the scenario in the 40s and 50s, and therefore industry so far was not impacted so much even by software, for that matter, to talk about AI impact. Okay, but Industry 3.0 onwards, what we started seeing was a lot of these automations started coming in, and in these automations, we have a lot of uh, impact that started coming with respect to software, and also within software from various uh, AI related developments which are happening. Okay, so when we are taking a look at Industry 3.0, there was a lot of mechanical automation which came in. Okay, and at the same time, this was also aided by a lot of rudimentary AI related automations. Also, concepts like TF-IDF, deep learning, all these things started coming in, and we started getting all these benefits. Just give me 1 second, Abhishek. 1 sec.
Sure, sir.
I want to stop all these pop-ups which are coming so that. you're not disturbed by that. Give me a second. Okay, hopefully that will take care of the. Let me know, Abhishek, if I'm.
Yes, sir.
It's visible.
The screen is visible, sir. Yes.
So hope all those pop-ups will now go away.
Sure.
We were talking about automation, and a lot of the the improvements in machine learning, etc., also started coming in during this time. And deep learning, etc., came in, which really changed the ML scenario itself. And that is where we see consequently an impact on the industry also, where digitalization started picking up pace. Okay. Now, of course, when we are talking about Industry 5.0, where there's a lot of personalization, that's where things like NLP, NLU, etc., NER, all these concepts started coming in. And of course, in the last 3-4 years, we have these concepts of the transformers, which have actually transformed the ML scenario and brought in LLM. So I just wanted to go through this kind of a historical perspective before we deep dive into AI and ML. Okay, so having talked about now, let's take a look at the various facets of AI. So when we are talking about AI, we have the very basic machine learning, where you have the typical training a machine to start learning the way humans learn, and more of artificial neural intelligence, etc. We are currently, what we say is, we are in the middle of stage 2, where we have not yet hit AGI. AGI is nothing general intelligence, but at the same time, we have made pretty good advances in the concept of machine intelligence. Okay, and the ultimate, machine learning utopia or grand plan would be when we can actually achieve artificial super intelligence. Okay, where the machine consciousness comes into the picture and machine capability goes beyond human capabilities as well. Okay, so you might have, of course, come across all these Chat GPT and Llama and all. They are able to now pass most of our engineering entrance exams and lawyer exams, and even these finance and economics related exams, etc. So that's where we are right now, and we are taking a look at maybe reaching ASI a few years, if not a few decades, or sooner as well. So that's where we are in the overall scheme of things. And if we take a look at how this field of AI evolved, so first, when we talked about data and computerization, it was all about putting the data into a digital format. Okay, so you started having data. Then you started having data warehouses and data analytics. Okay, where you could actually slice and dice and generate reports, to tell you some, that typical data pyramid also. So you have, raw data, then you have, massage data, then you have information, and then you have knowledge, and then on top of that you have insights. So that is something that you could achieve with data analytics. And then within data analytics, when you're talking about something like an enterprise data analysis, or EDA and all these concepts, that's where AI came into the picture. Within AI, you have this subset of machine learning, where you can actually train machines to learn the way humans have been learning. And then how to speed up that learning and how to make it much more powerful. That's where the concept of deep learning came in. And finally, now a subset of deep learning is where you have generative intelligence, where after you have done all the learning, you can actually generate content and output, which is very tough to discern whether it's something generated by humans or generated by the machine. Okay, so that's the current scenario around deep learning. Okay, Now taking a look at the various types of machine learnings, again, we don't, each of these subjects, please bear in mind, each of these subjects is something that you can spend, so just, I'm in the last week of doing a 3 months course on machine learning from IIT Kharagpur. Okay. So you can very well imagine, so something like a machine learning topic, we cannot try and cover within say an half an hour. So I'll not go into too much detail. But at the same time, what I want all of you to achieve from this session is, for those of you who are experts in AI and ML, all this will be very basic information. But my idea behind this session is to try and have everyone in this audience, when they go out of this meeting, all of you should have a general idea at least about the various terms that are being spoken about these days in the industry. Okay, so that's why I'm trying to the entire field of machine learning, traditional ML as we call it, I put it in one single slide, and I'll try and cover it in the next 5 minutes or so. So please bear with me. Okay. So when we are talking about machine learning, so there are these various options which are available to you. So the first option is supervised machine learning. So this in the best example I can give is what all of us go through in our school days, right? So when we started our schooling in pre-primary or primary, etc., we had supervisors or teachers who were telling us that, okay, this is an apple, this is an orange, and these are another picture of an orange, this is another picture of an apple, etc. And that is how our brain started learning that, okay, if I'm told that this is something, I can actually try and recognize, so that next time I get two more images, I can try and, so if I don't know if all of us remember our junior KG days, but I'm pretty sure this is how we were taught, right? So we were taught that, okay, this is an apple, and then we were probably shown another photo, and we were asked that, okay, can you tell what is, where is an apple in this collage of photos, where is an orange, can you identify, right? So that is exactly what we are trying to do with machines when we do supervised learning. So basically what we do is we label certain data. Okay, so that is why it's called a labeled data set. And that labeled data set, you have certain mathematical algorithms or statistical algorithms. Once you provide this labeled data to these algorithms, they are able to learn that, okay, what are the features? So, when you train these algorithms, they are actually able to go into the deeper, aspects of these. So, for example, if we are talking about, say, pictorial data, okay, like this, so apple and orange, the algorithms are able to actually make out that, okay, this is an apple and this is an apple. Let me try and identify what are the common things between this and the other photos belong to an orange. So I'll try and identify what is common between the oranges. And I'll also try and learn what are the differences between an apple and orange. Okay. So all I have to do is, instead of having to, define, okay, an apple is typically red in color, it has, green leaf around it or something like that. And an orange is orange in color, and it has more, spotty texture on the skin, etc. So instead of me having to tell the machine what actually is an orange and what is an apple, I'm letting the machine itself try to figure out. Okay. And how does it figure out? By giving this labeled data. Okay. So that is why it is called learning, where you are providing labeled data to the machine and the algorithms, and the algorithms are able to make out, okay, what are the features. So you'll typically hear these terms being talked about: feature engineering and feature identification, etc. Okay, so the machine is trying to learn what are the features, what is common between these two apples, what is common between these three oranges, and what is the difference between an apple and an orange. Okay, so that the is given new data, test data, it is able to correctly predict that, okay, this is an apple, this is an orange. Okay, so that is your typical supervised machine learning. In industry, it is wherever you have these labeled data sets which are easy to provide, and your business problem is more around prediction. Okay, so if you want to predict what's going to happen. So if I take a industry use case, customer churn. Okay, so customer churn is a typical prediction use case where, say, if I'm a Vodafone or I'm an Airtel, I want to predict if if one of my customers who's taken a SIM card from me, suppose I am a Vodafone, and I want to make sure that he stays with me, right? So that he keeps every month or prepaid, postpaid, whatever is the user, he keeps giving his money to me. Is there a chance that he will, switch from my Vodafone services to say an Airtel? I would like to predict that. So that is where we will try and provide data to the algorithms of customers who are continuing with Vodafone and customers who have left Vodafone, and we'll all give all sorts of data to it. So we'll give it, their billing data, their usage data, how much data did they use, how much talking minutes did they use, etc. How many tickets did they open? Were they unhappy with any of the services? What kind of feedback were we getting from social media, etc. So the entire data we'll give, and we'll tell the algorithm that, okay, these are the customers who are continuing with us, and these are the customers who have left us. Now understand the features, and now I'll give you a fresh customer data and tell me how likely is he to leave me and go to an Airtel. Okay, so that is a customer churn prediction, a typical use case for supervised machine learning. Okay, so that's your supervised ML. When we are talking about unsupervised learning, it's basically where we don't have any label data. And one more thing to mention is these prediction algorithms and everything. While you and me as humans, we have, at least so far, we have better intelligence in the machines. So maybe given 10, 20 photographs, we can start making predictions. Okay, but a machine typically requires labeled data in at least tens of thousands, if not millions of records. Okay, so that is where this, and we'll take a look at why ChatGPT and all have become extremely famous. So typical supervised machine learning problems used to take months because you had to label hundreds of thousands of data and then train the algorithms to be able to predict better. But what if you have a scenario where you don't have this labeled data? So and you have a huge amount of data. So what do you data? You do unsupervised learning, where you tell the algorithm, you give the entire data set, and you tell the algorithms you only try and decide and categorize. Okay, so instead of prediction, this is typically a categorization or classification kind of a problem, where you give a bunch of data to the algorithms and they will come up with various categories. Okay, so this is if I take a industrial use case. I'm currently doing this for one of our clients. That is your document classification. Okay, so when they have these, so currently that we had this use case where one of our clients, they had these. They were into the sustainability, that department of that client, and they had lots and lots of material which had been built over the years, and they wanted to categorize that data. Okay, which of this material is actually related to decarbonization versus which data is about alternative fuels, etc., like that. And we gave it to an unsupervised learning algorithm, and it was able to then categorize it into different categories. Okay, so that's your typical example of unsupervised learning. And then you have semi-supervised learning, where sometimes you first use unsupervised learning to get these categories. Then you are able to make out that, okay, this seems to be brinjals, this seems to be onions, this seems to be capsicum. So now I will just blank, go ahead and label all this data as capsicum, all this data as brinjals, all this as onions. And now I can actually feed it to a supervised machine learning algorithm and start making predictions. Okay, so that is kind of like a example of a semi-supervised learning use case. And then reinforcement learning is another type of learning where essentially you are giving a goal to the machine and you're telling it, in one way we say reward versus punishment. Okay, so every time the machine takes a decision, we have certain conditions where it can make out that, okay, this is the decision that I took deserves a reward, or does it deserve a punishment. Basically the machine is able to make out whether it is reaching its target or not. Okay, so every time, so you have an environment, the machine takes an action, and then based on the action and the observation, the machine can make out whether it has supposed to get a reward or is it supposed to get a punishment. So this is a typical example of a maze, solving a maze problem, right? So this is typically an industrial use case. If I may put your autonomous vehicles. Okay, so you have the so when you are hiring this Tesla cab, all you have to do in the Tesla cab is you have to tell it that, okay, I have to reach XYZ destination, and then the entire the navigation and which route to take, which route has more traffic, which has less traffic, which route is closed, etc. That entire decision making, and then the actual driving on the road. So all of that, making sure you're not hitting another vehicle, making sure that you are following all the traffic rules, the signals, the speed limits, etc. So all that is the environment, and then you have given it a target, and these reinforcement learning algorithms are able to take actions so that they reach the target. Okay. So that was like a quick 5-minute introduction to traditional machine learning. Okay. Now I'll quickly skip to a data point where we are saying that as of last year, we were seeing that of AI projects, about 90% of projects were traditional ML, and only 5-10% were generative AI, and still a lot of these projects are still in POC mode. Though we, in the last 3-4 months, we have started seeing a lot of our POCs actually go into production. Okay, but in the next 5 years or so, what we are expecting that the picture will change entirely. We'll have almost percent of projects around generative AI, and only 10% of them traditional, and we'll start seeing some projects coming in on the AGI, the artificial general intelligence that I was talking about. So what I'm trying to explain here now is why is it that we are seeing this shift, okay, or we are predicting this shift. So if I take this, the typical AIML life cycle, usually it starts with the business requirements, and then a big amount of effort actually gets spent in this portion where you collect the data, you have to explore the data, you have to prepare the data, and then you have to do the model selection and model evaluation. Okay, a lot of times is spent in this. So if I take the case of one of my projects, we delivered 5 use cases of traditional ML to our client. There was a team of about 10-12 of us, and we literally slogged for a year and a half. Okay, for those 5 use cases. And when I say slogged, almost every month, maybe 2-3 weekends was spent working, and every normal working day also stretched well beyond 9 hours. Okay, so with a team of 10, it took us 18 months to deliver 5 use cases, and so if I take 5 use cases in 18 months, around 4 months, per use case, and out of those 4 months, almost 2 months or so was spent in this data collection to model evaluation. Okay, phase. So because as I was talking about, so you have millions of records which you need to train, if not millions, at least 100,000, if not 100,000, at least 10,000, etc. Okay, so the data labeling, collection, everything is something that actually takes care, takes bulk of your time. So why is it that generative AI suddenly, and then of course, why is generative AI actually, or ChatGPT or all these, why have they created such a buzz? Because in the case of generative AI, that entire data analysis, preparation, model selection, evaluation, etc., is taken care of you, because you have something like a ChatGPT or a Llama model available to you on day one. Okay, so you don't have to do any of that activity. Okay, all you have to do is you have your data, you have the the ChatGPT, Llama, Gemini, all these. So Google solution is Gemini. So you have the Gemini LLM available for you, and you just send your data to the LLM. You ask it a certain question, and you will get the answer for it. So this entire and then we are into n, which is the number of use cases. So I was talking about 5 use cases. So each of those use cases, we had to actually repeat this entire cycle, uh, go through it, label the data for each use case separately, do the model training, model evaluation for each of these use cases separately, etc. And now my same LLM, so the use cases that we were talking about were, language related use cases. So we had to classify an email, we had to classify documents, and then we had to extract certain data from the email body, and we had to extract certain data from the documents. Okay, there were 2 different types of documents. So that was the total 5 use cases which you had, and it was all language related. Okay, so now with a language LLM, large language model like say a ChatGPT or a Gemini, all you have to do is I can send that email body to say Gemini, and I can ask it, okay, tell me what email is this? Is it an email which is is it a customer grievance, or is it a customer asking for opening some new service with me, etc., or taking some new product from me, etc. So is it a sales email or is it a service email? Okay, so an LLM can easily understand the language and tell us that classification. Okay, similarly, if I provide the text of a document and I ask it what kind of document is it, the LLM can immediately tell me within seconds what document is it? Is it a decarbonization document, or is it, say, alternate fuels document, etc.? So like that, it can immediately understand because of the power of these LLMs. Okay, so that's the so that's the whole magic of large language models which have come up, because they have been trained on huge amount of data set. And now all you have to do is just adapt it for your particular use case. Okay, so that's your typical LLM, why they have got the fancy of everybody. And just to show certain size related, so when we say large language models, right? So we started with BERT, etc., which were dealing with thousands of data points, and now we have all these models which are like 200 billion, 300 billion parameters on which it has been trained, and it is ready to act on. Okay, so that's how. In fact, they have now become so large that in the last few months there is also a lot of development which is happening on small language models. Okay, because obviously large language models require that large compute, storage, etc. So now for very specific use cases, if you want to use these large language models, you have this concept of small language models also, which are available. One more thing which I forgot to highlight in this particular slide was that earlier, as I was saying, for 5 different use cases, I had to actually train 5 different models, right? One model for email classification, another model for email the document classification, one more model for email entity extraction, another model for the document entity extraction, etc. These LLMs, because they have been trained on so many different parameters and so much data, that one single ChatGPT LLM or Gemini LLM is able to take. Okay, so that's another, that is why I was showing this multiplied by n, where you don't have to have different LLMs for each of the use cases. One single, and this is in a way where I'll say not exactly correct statement, but our models have now become more general in nature, and in a way we are progressing towards artificial general intelligence. Okay, one way to take a look at it. Okay. So now, taking a look at some of the industrial use cases of generative AI. So, on the marketing and sales side, you can do a lot of creating translations, etc., creating code, writing code. So we are currently at least 3 projects I am aware of where we are helping our clients move from. So I talked about that Foxbase and Fox Pro and all that, right? So we are helping migrate COBOL code to Java. We are helping migrate, SQL queries, Oracle SQL queries to PostgreSQL queries, etc., like that. So, those are some of the typical code-related capabilities which are there with these models. Then creating summaries. So these are another, way. Creating documentation from, code or from diagrams, etc. So these are some of the typical use cases of Gen AI. And then concept of multimodal Gen AI also, where the same Gen AI model is able to take care of different realities. So you can throw a text at it and ask it to generate a video. You can throw a video as an input and ask it to summarize it into text. You can give it an image and ask it to generate another image, or you can give it an image and ask it to generate a video from it. Okay, so all these kinds of multimodalities are available to you. Okay, so that's your multi-modal LLMs, which are also coming in. And then there is this concept of challenges with LLMs also. Okay, so hallucination, very famous example. And what I'm trying to show out here is three examples where I myself face this hallucination problem. In the first one, I was asking DALI, which is another generative AI foundation model which generates images for you. So I had actually asked it to generate an image which has all four modes of transport. So road, rail, air, and sea. I asked it to generate an image which has all four modes of transport in it. Okay. What it ended up doing was it brought in the water, but it missed out on generating a ship for me. Instead, it created two aeroplanes. Okay. So this is an image kind of a hallucination issue. Then in between, I'm showing one example where Amazon Titan is another generative AI model, and I asked it to generate an architecture diagram for a particular claim processing website. Okay, so it generated a picture which at the initial thought it looked like okay, this looks like an architecture diagram, but the moment I took a few seconds look at it, I could make out that it was not at all making sense in any way. Okay, first of all, the text itself, it doesn't look like it is any particular language. It seems to be just random drawing of what appears to be words. Okay, and even the boxes, they are not really an architecture diagram kind of a box, right? So basically it just said that okay, here's an architecture diagram for a claim processing website, but obviously it was not correct. And then simple hallucinations when it comes to numbers, etc. So I asked it which is a larger number, 1.09 or 1.01, and then it said that okay, 1.011 is actually so first it said 09 is actually larger than 011. But then when I said that, okay, are you sure? I think this is large. It immediately said, okay, I made a mistake. Let me recheck. And yes, you are correct. 1.01 is larger than 1.09. Okay, so like that, there are a lot of these challenges with the models because they need not be giving the correct answer. On top of that, so basically you cannot just directly throw a question to these models in the enterprise use case scenario. Okay, so for example, if I were to ask ChatGPT, okay, which is the best Vodafone plan, okay, postpaid plan for me, how will it know, what is the best plan, right? So maybe it might reply back to me, okay, this fellow seems to be located in India, from the cookies or something, if it can find that information, and then maybe give me a general idea about plans. But suppose I'm deploying this LLM for Vodafone, asking which is the best plan for me, etc. I want this LLM to actually figure out who is this customer, what is the current plan, what is the current usage, and then what are all the plan options that I have as say Vodafone, which I can actually propose to the client. And then based on the data about this particular client and about my Vodafone plans, I should be able to answer better. Okay, so how do I train this LLM to answer based on the data of my clients and based on my enterprise? Where the concept of various ways of improving your LLMs comes in. Okay, so the first method is where you do prompt engineering, where you design the prompts. So there are various again, we don't have time to go through each of these in details, but you have something known as few shot prompting, one shot prompting, zero shot prompting, etc. So you give certain examples. Then there is something known as chain of thought. So you provide a chain step-by-step process by which you can actually ask the LLM to respond to you. Then you have the mechanism of RAG, or retrieval augmented generation, where you can actually have your enterprise database available to the LLM. So it can actually refer to that database and give you the solutions. Okay, and then finally you have the option of fine tuning the LLMs also. The left to right sequence is basically we are trying to show increasing complexity of fine tuning these models, and at the same time increased quality also. Okay, so prompt engineering is basically the least complex or the easiest way to try and customize the LLM for your use. But having said that, the prompt engineering might not get rid of all your hallucination and other issues. Okay, retrieval augmented generation is it's something that might take you a month or two. I'm actually currently doing a project for one of our clients, and we were able to enable a POC for it within a matter of 1 week. But now that we are talking about putting it into production, it might still take us a month or 2 months to actually take that POC to production. Okay, so but then in a matter of say a month or 2 months with a team of 3 of us, we should be able to get this working for our client. At the same time, the quality is much better now than prompt engineering, because now the LLM is looking specifically at certain data and databases which we are asking it to focus on. So there is very little chance of any hallucination or incorrect answers going out. Okay, but at the same time, it's still a best case or a best guess kind of a scenario from the database. Okay, the most complex customization of a LLM is by fine tuning, where you actually have to spend a significant amount of time as well as money, because these LLMs, because they are trained on so many different parameters, billions of parameters. Typically, this training does not happen using your normal CPUs. Okay, we have to use GPUs or graphical processing units. All of you might have heard, how the shares of Nvidia company have zoomed up in the last 2-3 years, because that's one of the top GPU making companies in the world, and these LLMs require GPUs. So something like a ChatGPT or a Gemini, it requires sometimes as many as 5 to 10,000 GPUs working for almost 3 to 4 months to come up with the next version of your Gemini or a ChatGPT. So fine tuning, say a Gemini model for your use case. Basically, what you do in fine tuning is you retrain the Gemini or ChatGPT model which is available out of the box. You train it based on your specific data, so that the model itself becomes knowledgeable of your data. But as you can imagine, so that requires a decent amount of GPUs and a decent amount of time. So time and money both are required to perform this. But once the model is fine tuned, now it will give you the best quality output in the shortest amount of time. Okay, so that way this is expensive, complex, but provides the best results. Okay, versus prompt engineering, which is cheapest, hardly much effort required, but it might still be prone to issues like hallucination. Okay. So with that, I will try and take a pause here on this. I've tried to cover traditional machine learning all the way till generative AI. Yeah, one thing I forgot was I'll not go into the details of this, but yeah, we'll talk a little bit because we've been talking about the Google platform. So I've put together a couple of slides. Again, all of this information is available on the internet. So the various services which are provided by Google platform for this enabling AI. So right from the infrastructure, so you have CPU, GPU, TPU, etc., which are available for training. So infrastructure as a service, to your platform as a service, where you have in training, all these functionalities. You have Google BigQuery ML, which is in itself a AI-enabled solution. And then you have various PaaS and SaaS kind of solutions. So dialog flow for your chat, contact center AI, document AI, etc., which are available for you to use. And then specifically with respect to generative AI, you have Google Cloud Services. Vertex AI is their primary enterprise solution. And then you have prompting possibilities. You have the model garden, where you have a lot of these LLMs and foundational models which are available. And then you have Google Gen App Builder. which can help you generate generative AI, questions. I think the next slide, yeah, this is where I have also tried to talk a little bit about the similar options are available from Amazon and Azure. Okay, so which platform you choose and which one you actually end up using is entirely up to you. But this is an architecture of a RAG solution using Azure. So I've used Azure Blob Storage, Azure Functions, Azure AI Vision, Azure Web Chat, Azure OpenAI as the LLM, and then Azure Postgres database as the database. So just like you have these services from Google, you have similar or equivalent services which are available on Azure as well as AWS. Yeah. So yeah, I think that is the end of my talk. We can now throw it open for questions, Abhishek.
Sure.
Let's say yeah.
Sir, I've enabled the chat option.
Chat. Okay. About ASI and AGI. Okay. So, to be honest, Mithun, even I'm not an expert on AGI and ASI, but AGI is essentially artificial general intelligence, where it's like mimicking human. Okay, so just like you and me, when we step out in this world, we don't know. Like, suppose this meeting is done, and you step out from your home, or you step out from your college, or company, etc., or you just meet your friends, etc. You have no idea, right? What is the next challenge or next question that life is going to throw at you? So similarly, AGI, when we are talking about AGI, we are trying to mimic that human scenario where you can throw any and every question at these models, and they should be able to answer. So whether they have been trained or not trained, whatever they've been trained on, can they try and generalize that learning so that you can actually start answering. So that's in short about AGI. And ASI is where you actually go beyond human capabilities, and as we said, machine consciousness and all comes into the picture. So can you actually have a conscience and then try and answer your questions also? Okay, so that's in general, but it's something that I'll also take it as a homework to try and learn more about these. Okay, I hope I could somehow answer your question, Mithun. Ganesh, is RL like a trial and error, or please explain it again? Okay, so reinforcement learning, again, see, as I was saying, each topic can take hours or days, but reinforcement learning, yes, in a way, I think you've captured it well by saying trial and error, but trial and error with a goal. Okay, so in mind, goal you have to achieve, and then you have the environment, and then you take an action, and then based on the action the environment will react. Maybe a good example can be, if you can take a look at, I think there's the what was that snow sliding game. Okay, it's available on the internet, so you can actually start coding it and see how it works. So basically it's like suppose you are on no surface, and you have to slide from one end to the other end, but you don't know exactly in your path where it is very slippery. Okay, so when you are actually telling the computer to take a right turn, it is trying to take a right turn, because the snow has made it slippery, it ends up taking a left or a some other turn. Okay, so it's basically uncertainties along the path which you don't know in the environment, and you just so the machine, you're not trying to tell the machine that okay, you have to take this action. You tell it that you have to go reach this particular target, and based on that, it will try and take the best action. Every time it takes an action, it is going to try and get a feedback on that action. Was it a rewarding action or was it a punishing action? Okay, and then basically it will try and
Yes.
respond to it. Yeah. Hardware does anyone type? This is something else. Going to regarding exam. Is human interaction required for results of models in Revolution 5.0? Okay, so that's a good question, Vishal. So far, what we are seeing is human intervention is required, okay, especially when it comes to generative AI, okay. Apart from the human intervention, so one way in which we are seeing a typical use case in the industry for generative AI is they are still as I was saying, maybe till last year, 2023, it was all POCs. 2024, we have started actually putting generative AI applications into production. But still, bulk of the applications which are going live, they are not really focused at the end customer. Okay, so for example, I'm working right now on a client for a US-based healthcare insurance provider, and they are enabling a Gen AI-based RAG-based chatbot, but they are not enabling it for answering end user questions. They are enabling it for their customer service agents. So whenever a customer is having, say, a chat or a telephonic conversation with their agents, and he or she asks a question, the agent, that audio, we can convert that question from audio into text, and it will go and hit our Gen AI-based chatbot, and the chatbot will come up with an answer, and the agent can read that answer that the bot has generated, and then respond on his own to the end customer. Okay, so that is how human interaction or intervention is still being put in between the customers and the latest Gen AI models. I think it's a matter of say 6 months, 1 year more. As businesses get more confidence out of this technology, I'm sure human interaction will slowly start going down. Okay, so I hope I could answer that. Raj, considering the use of AI in different industries, free from biases, okay? High stake areas like hiring, lending. Okay, good question, Raj. So again, bias handling, is probably one of the concerns why we still have this human interventions still coming into the picture. Okay, now the way you can get rid of bias, manually is very difficult because finally it's humans. If we are labeling the data, we are providing the data to the models. It's quite possible that we might be biased. So I don't know if there is a perfect solution which has been found so far to get rid of bias. But at the same time, maybe more and more automation that comes in, where the machine itself is trying to identify what it needs to be trained on. That can be one possible solution. But at the same time, you'll have to put in some checks and balances to make sure that whatever it has selected also is not biased. Okay. So I don't know if there's a perfect solution to it, but yes, industry is taking a look at this. So various efforts are underway to take a look at how to solve this problem. Okay. Raj is asking, generative AI models often have to balance creativity with plausibility when generating content. How do they manage this trade-off, and what methods or metrics do we use? Okay, so there was actually, when you're talking about methods and metrics, I had a few slides which I didn't go into. So there is something, so I was talking about this RAG evaluation, right? Where we are in our RAG solutions, what we are trying to do is we are having the enterprise database. And when a user asks a question, instead of sending it directly to the OpenAI model, I will first try and find out the most, possible best guess database, documents which are related to this query, and then that database entries which I picked up. So suppose I have 5,000 documents, and the user has asked a question, I'll try and find out, okay, the top two matching documents and give that document along with the user question to the LLM. And then the LLM will decide, what is the answer. Okay. So now in this particular scenario, there are multiple ways to measure, the accuracy or, the functioning of the entire solution, right? First is this selection of the top two, best matching documents for this question. So I have to evaluate that. Then the second thing is, having given the context to the LLM, how correct was the answer, that the LLM provided. Okay, so that is where things like, RAG evaluation, RAGAs, deep eval, there are quite a few frameworks which are there, which are coming in, which measure all these metrics. So, context precision, answer relevancy, faithfulness, context recall, etc. So these are some of the matrices which are used for measuring these generative AI solutions also. Okay. So good that you asked that question. I was trying to get the answer over there. But I don't know if I completely answered that question, Raj. So the balance between creativity and plausibility, the simplest answer can be the setting called as temperature. I don't know if you guys are aware. So most of these, generative LLMs and foundation models, they have this feature called, temperature, where you can, ask it to be creative. So the higher the temperature, so it ranges typically between 0 and 1. So if you give a temperature of 1, it is, I think, the most creative. Might be a little, circumspect on the plausibility. And if you give the temperature as 0, it will try to be least creative and maximum plausibility. Okay, so that's typically how these things are measured. I hope I could answer your question over there. Okay. I am not seeing for the, okay, yeah, there are a few questions that I see. Sorry, there was somebody at the door. Take care of that. Maybe we might have to create an AI to balance versus, yeah. So good thought. Are we done with all the questions? Anything from the previous chat history, Abhishek, which I might have missed, which you want me to answer?
Sure, I guess we have covered most of the queries.
Okay.
Probably we can conclude and wrap up the session.
Sure. Okay.
Sure.
So I'm done actually. There's nothing else we can.
Okay, sir. So
Yeah.
I would like to thank you for being a part of this session and taking out your valuable time to
Sure.
train all the grand finale participants of Smart India Hackathon 2024. It was
Sure.
really an honor to have you, sir. Just an announcement for all the candidates. We have organized further sessions under different categories, for which we have already sent the lineup for week 1 and week 2. Request you to kindly go through the mails and accordingly join the WebEx and YouTube links. Thanks for joining. Thanks for being a part of the Smart India Hackathon 2024 Grand Finale. Thank you, everyone. We are concluding the session now. You may leave the session. Thank you, Hemant, sir.
Thanks, Abhishek. Thanks a lot to all the participants. Hope it was useful.
Thank you, sir.